This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. Now, in some questions you might be given trigonometric functions on graphs and asked to identify them. So we've looked at so far how we can identify the range and the period on a graph, but now we need to look at the difference between cosine and sine themselves. And the difference is that if we look at this graph of sine x down here, we see that sine will always pass through the point 0, 0. So when our x is 0, means we're going to get y is 0 for sine x. And if we look up here at our graph of cosine x, we see that when x is equal to 0, we have y is equal to 1 instead. We're at this point here. So that will help you distinguish between cosine and sine. If your graph passes through the point 0, 0, then your function will be a sine function, and if it passes through 0, 1 or 0, 2, depending on what the a multiplying your cosine is, in this case it's just 1, you'll have a cosine function. Here I just give an example of how you would go about plotting one of these functions if you were just told to plot. In this case, we're asked to plot y equal to 2 sine 2x. So the easiest way to do this is to make a table. So you'll have your x values that you will choose yourself. In my case, I've just chosen to plot from minus pi up to pi, and I've taken various values in between those. So in this example, I'm working at radians. So then, to get the 2x inside, I need to multiply all those values by 2, which I do here. And then I need to get the sine of those values, which I do here. And finally, I multiply everything by 2 to get this graph down here, or the values for this graph. So at minus pi, I have a value of 0. At minus 3 pi over 4, I have a value of 2. And so on throughout the rest of this table, the first and final rows being the ones I'm interested in. And then we just need to look at the various properties of our graph. Since this is a sine, we know it'll definitely pass through 0, 0. And then there are some other key facts to keep in mind. Our range will be from minus 2 to 2. Our period will be pi, or 180 degrees. And we know that sine is continuous. So when you're drawing this graph, it'll be a continuous line with no jumps or gaps. And obviously it would continue on, but for the purposes I just plot between minus pi and pi. The only graph that will look slightly different is the graph of tan x. Y equals tan x. So in the case of tan x, I've just taken several values of x between minus 90 degrees and 270 degrees. And what you'll notice is that if you try to type, for example, tan of 90 degrees, your calculator will actually get an error. And that's because tan is actually not continuous tan is not a continuous graph because it has what's known as asymptotes at 90 degrees, 270 degrees, minus 90 degrees, and so on. So the graph of tan will have a range of minus infinity to infinity, because tan will get closer and closer and closer to these lines, but it will never ever touch them. If you tried tan of an angle very close to 90, you would get a very large value, and likewise for 270 and minus 90, the value would be very large, either negative or positive. So when you're plotting tan, you will draw lines that are discontinuous, or they have jumps from plus infinity. It drops suddenly down to minus infinity at 90 degrees, 270 degrees, minus 90 degrees, and so on.